So look at this. Look at what this is saying. We have now moved from sequences to series. What's the difference between a sequence and a series? And again, it's not defined here. It's not fair. Let me define series for you. A series is just the sum of a sequence. See, a sequence was a list of numbers, right? A sequence was a list of numbers. The series is the sum of those numbers in the list. You add them up. Now, when would you ever need to add them up? Well, I showed you in the beginning of class. Pouring liquid into a thing, does it overfill? E to the x on the calculator is the sum of a bunch of stuff. So sequences are just to kind of get us started, but ultimately we want to deal with series more than we want to deal with sequences. So this first formula says S sub n, that this is the sum of first n, what do they say here? Doesn't say. N terms, okay, n. First n terms of arithmetic sequence. That's what that formula is. And you said you want me to see if I can show you where it comes from, or? I don't know, I haven't thought this through, so let's see. Let's try it. Let's make sure we understand what we're trying to show. We want to show that A1 plus A2 plus A3, all the way till you get out to A sub n, we want to show that that's equal to that ugly thing. See, if I take all the pieces of the sequence and add them together and stop at n, that it adds up to be that, right? So if I can show you that, you'll be happy? All right, it's an arithmetic sequence though. So I know that each of these can be written a certain way. Like a sub 1 is a sub 1, but wasn't a sub 2 a sub 1 plus d? That was the second one, right? And wasn't the third one a sub 1 plus 2d's? And wasn't the next one a sub 1 plus 3d's? You following me? Like this is a sub 1, this is a sub 2, this is a sub 3, this is a sub 4. And when would I stop this? All the way till I get to the last one. So it should be a sub 1 plus, how many d's will I have here? Yeah, I'm stopping at the nth one, right? So this will be n minus 1 times d. Yuck. Questions on that? Does that look like that yet? No, not there. Okay, so let's see. These are all additions, aren't they? This just adds, so I don't need those parentheses. Yeah? How many a sub 1s do I have? I have a sub 1, a sub 1, a sub 1, a sub 1, and I've got another one here. How many of those would there be? Whatever n is, right? So like if I stopped at the third one, right? If I stopped at the third, I would have 3 a sub 1s. If I stopped at the 10th, I'd have 10 of them. But I'm going to stop at the nth one. So do you agree that this is equal to n times a sub 1? Can we agree on that? The underlined part in blue are n a sub 1s. I see squinting eyes. You need clarification? Yes? Okay. Let me get rid of the parentheses. I think what's most likely confusing is the dot, dot, dot in the middle. Because you're like, what happened? You know, like it just keeps going. It stops. This one right here is the a sub n. So what I need you to see is that if I stopped, let's say if I stopped at the third, if I were to stop at 3, if n was 3, it would be this one, and this one only, right? So forget all this. How many a sub 1s would I have there? How many of these do you see? 3 of them, right? That's controlled by this. If I went to a sub 4, I would have this one there also, right? So now I have 1, 2, 3, I have 4 of them. But I'm not going to stop at 3 or 4. I'm going to stop where? At n, right? The nth one, which means I'm going to have n of those a sub 1s. And that's n times this. How many d's do I have? Oh, I see it now. Shit. I'm not sure I'm going to be able to show this to you now.
It's okay, we forgive you.
It's, yeah, well, I can show it to you, but it's going to eat up in time. But okay, so let's just see how many d's we have. We have 1d, right? That's the only thing that's left, right? Everything that's left is d's, right? It's 1d plus 2d's plus 3d's plus 4d's, right? It's just 1d, 2d, 3d, 4d. When do I stop? How many d's? N minus 1. So I need to say plus dot, 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 and I stop at n minus 1 d's. Do y'all agree with that part? What do all of these have in common? What do they all have in them? GCF. They all have a d, don't they? So I'm going to factor a d out. Yes, I'll be able to show this to you. Plus d. Now, if I pull a d out, what do I have there? Well, I have 1 plus 2 plus 3 plus 4 plus, and I stop where? N minus 1. Y'all okay with that? You still want me to show this to you? I have to do a side note. I have to do a little auxiliary little problem over here, so I apologize. I wasn't expecting this, but it's within grasp. We can do it. Sorry, I'm not sure if Ms. Manchester is going to watch this video, but I'm apologizing ahead of time. All right. So this is a common sum, all right? This is something that's come up before. It comes up a lot. If you take 1 plus 2 plus 3, and you stop somewhere at n, there's a formula to be able to find that sum. The formula is this: n times n plus 1 divided by 2. Now, I think it's worth showing you that it works, first of all, and then I might even show you where it comes from if you're interested. So look, what's 1 plus 2 plus 3? Tell me what that is. 6, right? That's 6? Okay, so it's all right. Where did I stop at? What was my last number? 3? According to this formula, if you take the last number and you put it in here, you get the same answer. So let's see, if I plug 3 in there, I get 3 plus 1 over 2. Isn't that 3 times 4 over 2? Right? Isn't that 12 over 2? Isn't that 6? So it works, right? But it works for any number. So if I go to 6 and I want to add those up, right? Then you could do like, that's 3, and then there's 6, and then there's 10, and then there's 15, and then there's 21. So 21 should be the answer. But according to this, if I just take 6 and plug it in here, I should get 21. Let's see. 6 plus 1 over 2. So that's 6 times 7 is 42 over 2 is 21. It works. Can you take this on faith for right now? Can you take it on faith? All right. So if you're taking that on faith, if I say 1 plus 2 plus 3 plus all the way out to n minus 1, if I take this and add them up, then this is equal to something, right? Well, according to this formula, I just take this last number and I plug it in right here for n. So this formula would actually, I wouldn't put n here, I'd actually put this, right? So I'd have n minus 1 times what? N minus 1 plus 1 all over 2. And something interesting happens there. We get n minus 1, and then this is just n all over 2. If you follow that, that's where we are. That's what's in here. That's what this is. Right there. All right, so now we have n times a1, that's this, plus d, and then I just tried to convince you that this right here is this. And I'm just going to write it a little different. I'm going to write n times n minus 1 over 2. Do y'all see it yet? It's there. It's right there. From here to here is one step. What's the step? I'll give you a hint. G, C, F. What do both of those terms have in common? What does this and this have in common with one another? They both have n, right? N here and n here. Now, this is a little tricky, but it looks like they pulled an n out and a 2 off the bottom. So watch me take this and pull an n out and a 2 off the bottom. If I did that, then what would I have to have right here to get back this? Wouldn't I need a 2a1? See, think about this. If this multiplied times this, the 2's would cancel, wouldn't they? And you would get the a1 times the n, which would give you that. And then I'd have plus. Now I pulled this n out, didn't I? That n's gone. I pulled the 2 out. That 2's gone. So all that's left is the n minus 1 and the d. What's that? Check. Works. That's where it comes from. I'm just the messenger. Sorry. What do y'all think? I didn't need to show. Maybe I shouldn't show the next one, huh? Should I just leave the next one alone? Yeah? I'll leave the next one alone. This, however, I'm sorry, but I have to explain it. I have to. I feel like it's not justified that the math world is not balanced out if I don't explain that. Because there's actually a really cool story that goes with it. Okay, I'm going to try and show you this formula. We'll come back to that. All right. So the story, there is a true story that goes, well, it's argued whether or not it's true. There's a very famous mathematician. Did y'all do elimination in here? Solving systems of equations? Y'all did a thing called elimination? The person who actually developed that method and proved that you could do everything you can do, his last name is Gauss. And it's actually called Gaussian elimination. Now Gauss, when he was in first grade, the story goes, that when he was in first grade, the teacher went into the class and told the students, all right, class, what's 1 plus 2 plus 3? And all the little first graders were like, 6. And the teacher was like, yes, good. And so the teacher then said, all right, what's 1 plus 2 plus 3 all the way out to 100? Please work alone, and when you're done, let me know. So in the story, it's that the teacher, I guess, had a bad day and didn't want to deal with the kids and was giving them busy work, all right? And Gauss was in this classroom. And yes, this is first grade, but this was like the 1800s, so the standards were much different back then, all right, than they are now. So this is, I guess, reasonable for a first grader back then. So within a few minutes, the story goes, Gauss, they used to write on like slate, like little chalkboards. So he took his little slate and he turned it over and crossed his arms and just sat there very obedient, because they had discipline back then too. So he just sat there and the teacher looks and sees him and gets kind of irritated and walks over there and turns over Gauss's slate, and sure enough, Gauss has this formula written down. Now, the formula, Gauss did not come up with the formula. He wasn't the first one to ever come up with it, all right? It was a known formula, but not by first graders. It wasn't normally known by first graders. So the teacher was like, who showed that to you? And Gauss was like, nobody showed it to me. And the teacher got all upset and thought he was like looking at it as cheating, you know, like you're cheating, you're using the formula. So Gauss had to explain to him how he came up with the formula. So I'm going to show you how Gauss explained it, and you might be quite amazed with how he did this, all right?
Talking about first grader, right?
We're talking about first grade. Yes, we are talking about first grade. So here's Gauss's explanation. And I'm not quite sure, well, yeah, I'll do it. So Gauss said, I'm trying to find the sum of these first 100 numbers, so I'm going to call it S. So Gauss wrote it down, 1 plus 2 plus 3 plus, and he said, you know, it's going to continue, and at the very end, I'm going to have something like 97, 98, 99, and 100. And so Gauss then explained, well, look, you know, I know that addition can go any order. Like you can add things and it doesn't matter the order you're in. So Gauss said, I'm just going to write that list of numbers down backwards. And the very last number I'm going to have is 1, and the one in front of that's 2, and the one in front of that's 3, and so on and so forth. So that's just the list reversed, right? And so then Gauss said, well, look, if I have two lists of numbers, I can add them together. It's like, you know, you have a bucket and another bucket, you can throw them together and you'll have two of them, right? So he said, if I add this sum to this sum, I'm going to have two of those sums. So whatever this side turns out to be is twice as much as what I want. But look at what happens. Just add straight down. What happens here? What do you get? 101. Plus, what's the next one? 101. What's the next one? 101. And every single one of these, all the way down, is 101. Right? All of them. How many of them are there? There's 100 of them, right? You have one of them, two of them, three of them. And if you are going to add something together 100 times, it's the same as multiplying it by 100, right? Like 4 plus 4 plus 4 plus 4, 5 times is 5 times 4. So Gauss just said, look, this is 2s equals 100 101s, right? And then he finally said, well, wait, that's twice as much as what I wanted. So I'm just going to take this answer and divide it by 2. See that? Now, if you follow that, it's pretty amazing, isn't it? And I'm lying to you in some way because I can't really present it to you the way he presented it, because even it's a little bit too much. So I actually have to put a little asterisk. This is not the way he did it. He was even better. What he did is he said this: you want me to add up to 100? I'm actually going to add out to n. All right? And he realized that the one before that's n minus 1. And the one before that is n minus 2. You follow me? Then he said, I'm going to reverse the order. And if he reverses the order, this one's n, and the one before it's n minus 1, and the one before that's n, or the next one is n minus 2. And when he moves it all the way down the end, the last one's 1, the one before that's 2, and the one before that's 3. Do you see the similarity in the setup here? But now when you add down, what do you get? What's n plus 1? N plus 1. What's the next one? N minus 1 plus 2, which is n plus 1 again. And then when you do these two together, n minus 2 plus 3 is n plus 1 again. Every single one of these is n plus 1. How many do we have? 1, 2, 3, 4, 5. We have n of them, don't we? So this sum, twice the sum, is n times n plus 1. But that's twice as much. Divide by 2. That's it. So I always tell my students that this is genius. This is what geniuses do, right? How many of you follow this? Okay? That's what a genius does. They take something that seems crazy and they find some simple, elegant way through it, right? I mean, most people can follow this. It's just that he came up with this on his own in first grade. Like, that's crazy. All right. So hopefully you believe the formula. There it is. There's more. There's other formulas, but that I needed that to show you what we were trying to do. All right, I've appropriately gone off on a tangent there. All right. Well, I guess it is what it is. All right, so we got these two formulas now, right, that help us add up sums. So let's look at part A here. It says find the sum of the first 30 terms, first 30 terms. She's never going to let me sub again. I already know it. First 30 terms of the arithmetic sequence 3, 8, 13, 18. So we want to add up the first 30 of these. And we're told it's arithmetic. Okay, it's arithmetic. If it's arithmetic, we use the formula S sub n equals n over 2 bracket 2a sub 1 plus n minus 1. Would you believe me if I told you Gauss went on to do brilliant things in mathematics? This is probably one of the top 10 mathematicians of all time? Okay, yeah. All right, that's the formula we'll use because it's arithmetic, right? So what do we need for this formula to work? We need A1. We have it, right? We need the common difference. Do we have the common difference? 5, 5, 5. We have D, don't we? And then we need N, which is going to be how far out we want to go. So we have everything we need. The sum of the first 30 is going to be 30 over 2 times 2 times a sub 1. A sub 1 is 3. Maybe I should identify that. That's a sub 1. Our common difference is 5. 5, so D is 5. And then what's this number going to be here? 29. And then times our common difference, which is 5. So that's just some arithmetic now, right? Where am I? Okay. I'm not going to work this out, just going to give you the answer. It's 2265. That's what you should get there. Questions on that? All right, for part B, it says find the sum of the first 10 terms of the geometric sequence 1, 1.05 squared, 1.05, that's all they give you? Oh, 1, yeah, it was, sorry. 1, there we go, 1.05, 1.05 squared. So this is geometric, and we want the 10th term. Now there's a different formula for this one, right? What's the formula for the sum of the first n terms of a geometric? Well, it's a sub 1 r to the n minus 1 over r minus 1. That's weird. I've never seen it written that way. Okay. What is a sub 1? We know that, right? We know a sub 1 is 1. What about r?
1.05.
Yeah, so to get r, all you have to do is take like this one and divide by this, or this one divide by this. Either one, doesn't matter. If they're telling you it's geometric, then this ratio has to be the same all the time. So r is 1.05. And we want the sum of the first 10. So I come here, S sub 10 equals A sub 1, which is 1, and then R, which is 1.05. What power am I raising that to? To the 10th, right? Yeah, it's 10. Be careful, that minus 1 is separate from, it's not up in the exponent. So this is to the 10th, and then it's minus 1 down here. And then all over r, which is 1.05 minus 1. And again, I'm just going to give you the answer. Is that fair or no? Yep, this is about 12.58. And these are not my answers, so I'm trusting that this was all done right. But if you can verify that, that's a good sign. Okay. We're on the last page, right? Look, why don't you try and do number 5 and number 6 on that back page right now? You know what I'm talking about on the bottom? We only have about 12 more minutes, right? You end at 2:40? Number 5 and 6. That's pretty much exactly what we just did, but you're not being told whether or not it's arithmetic or geometric. So you have to determine that and then use the formula. And when you're done with number 5 and 6, let me know. You're done?
Don't scare me at once.
Did you try 1, 2, 3, and 4 already?
I'm done.
You got it? Okay. Do you want to check to see if you got it? I'm not quite sure if you'll be able to make sense out of it, but you can take a look. Have you done sequences in series before? No? So okay, so good. So it made sense to you today. All right. I think I'm going to turn the camera off because I'm not quite sure there's anything else. There's nothing else new that I could do other than work out some problems. So every problem on